And this is our app. And on our app, you can see it's including two parts. First part is about remote account logging for both end user and service. And the second part is about local function. We can see there is a Bluetooth connection available here. So now we try Bluetooth connection. And then here we can scanning the serial number of inverter to connect to inverter. And we can also click the menu connection here. And then the app will show available devices nearby. So then we can click the device to connect it to it directly. Now I have one inverter behind me and it's available. Okay, now when the first time when we connect to an inverter, there might be a notification. For example, inverter time run. That means that's because inverter clock after a long-term shift is maybe different from your mobile phone. So he gives this notification. And here, usually we need to click OK to synchronize our mobile phone to the time of our mobile phone to inverter clock. And then now we reach the homepage of the app. In the homepage, firstly, we can see there is a power map, and there are several icons of PV, grid, inverter, and the battery. And in this power map, we can see the basic state of each part. For example, the PV now is in gray. That means PV is not connected or PV switch is off. And also grid is in gray. That means the grid is disconnected or grid switch is off. And now we can see battery is blue. Oh, there is a battery available. And also the generator and the backup load and the normal load. So from this power map, we can see the basic state of our system and the state of each part. Besides the power map, there is another, we can see there is a yellow speaker near the power map. Here we can click it and find the real-time alarm of our inverter. This is a very useful function because this yellow speaker is display the real-time alarm of inverter. So we can read the alarm and take actions to solve the fault. For example, now inverter is report grid under frequency, grid absent, grid under voltage. This three alarm that's about the AC side. So we can go to check whether grid is connected or whether AC breaker is off. And for example, the GN voltage abnormal, then we can go to check whether the generator have output voltage like that. And then the next one, D8, communication loss between inverter and BMS. Okay, that means there are something problem between the communication of inverter and the BMS. So in this case, we can go to check whether battery BMS is turned on, or whether the cable, BMS cable is correct, or whether the pin is matched. This is a very useful function on plant. We can see the real-time alarm of inverter. Then we take actions to solve them one by one. But here we can see I didn't connect AC, so it's giving this alarm. And it's give the alarm generator voltage of the number. That's also because I didn't put the generator input. And it's give the communication loss between inverter and the BMS. That's because I didn't insert the BMS table of the battery side, because even on inverter side I insert it, but in battery side I disconnect. Now I put it. Go back to the page and refresh it. Okay, now we can see the alarm D8 communication loss between inverter and the BMS is disappear. That means this alarm is cleaned and restored one. And if we put on AC and put a generator on, then the other alarms will also disappear accordingly. So this is, we can take actions according the alarm inverter report on plan to solve the problems. Just now we clean the communication loss alarm between inverter and the BMS, and now we can also slide down to check the details. For example, now BMS side share the battery information now is SOC is 20% and its temperature is 26 degree and the voltage is 15 volt. Okay, this is about the homepage, the power map, and the real-time speaker, real-time alarm list. And then on the homepage, when we slide down, we can see the detailed parameters of each part. For example, we can see the PV input information, its voltage, its current, and its power. We can also see grid voltage, current, and power, and also the load, the battery information, its SOC, its voltage, its current, and also the parameters of backup output, the parameters of generator port. This is about the homepage, app homepage. And then next page is the quick setup. Here we have a quick setup manual 1, 2, 3, 4, 5 to guide our customer how to complete the installation after they mount the inverter. First step is to configure the Wi-Fi connection, because many customers he will install the Wi-Fi dongle and do the remote setting, do remote monitoring. So he needed to do the Wi-Fi connection here. And the second step is to confirm the standard code of inverter. Inverter will set a default code when we doing our production. For example, in South Africa, it would be NIS 097. And here you just make a confirmation whether the standard code is matching to your country, and also we confirm the nominal voltage and the frequency. And also we double check the date and the time of inverter, because some customer may use the function of time-based control. In that case, in that situation, the inverter clock match to actual time is very important. We can click it to synchronize the time of inverter to our mobile phone again. Okay, the third step is about export power control. Because this is to set the devices. We select the device we are used for export power control. Defaultly, we provide a CT sensor together with each inverter, and here just select the CT sensor. If any customer he use a digital meter, he can select the digital meter. And then we can select whether we clamp the CT is clamped on grid side or is clamped on load side. Customer do the selection based actual installation. And then he need to select the power flow direction. On the CT sensor, there is a low mark here. In this part, maybe it's not very clear, but when you take a CT, you can see it. Power flow is from grid to inverter, or is from inverter to grid. So customer also need to do the correct setting according to actual installation. The meter location setting and the CT direction setting is very important for system running, because the CT is used to detect the power exchange between our system and the grid. If it's detected I purchase power from grid, then inverter will discharge battery or increase PV power. If we crank the city in wrong direction, it will wrong data, wrong value to inverter. In that case, inverter behavior will get wrong. So need to pay attention about this point when you install the inverter and when you do the setting. The last part is about maximum feed-in power. That it is to set the power, maximum power to feed to grid. If it's allowed to, if the plant is allowed to feed the power, you set the value accordingly. If it's not allowed, you set to 0. Then the system will zero feed into grid. The logic is, for example, the system is running and then customer turn off load, then there will be some excess energy and it will go to grid. At the same time, our city sensor will detect, can find, there are some power go to grid, then it gives signal to inverter. Currently there are 1 kilowatt power go to grid, and then inverter will take action. I reduce my discharge 1 kilowatt, or I reduce my PV generation 1 kilowatt, and then there will be zero export to grid. So this is the function of CT, and we can say it's export power control. Okay, the first step is about a hybrid setting. In this setting, customer can set the working mode. In our inverter, we have 3 basic working mode. First one is self-consumption mode, and the second is feed-in priority mode, and the third one is backup mode. Different customer install the system have different purpose. Some customers say, I just only want to self-consumption to reduce my electricity using from grid. But some customers say, I want to use it as a backup source. I want to back up energy to against the grid power outage. So it's like a backup mode. In this point, customer setting the working mode and the actual demand. And then here customer can also do the setting of battery selection. Here we have some white list here. And for your inverter, I'm not sure whether maybe it was in soda battery, so you can ignore. And then the fifth part is to power on, to start up the inverter. So we click the icon is to power on, power off it. Okay, we power inverter on, and then sorry, maybe some alarm didn't clear, so it caused the power on failed. Okay, this quick setup menu is also very useful to guide our customer, to guide our installer finish installation of a plant. The necessary step you need to do on the plant. This is a quick setup menu.